Good evening, can you hear me? Could you please give me a green check? Make sure you can hear me. Thank you. One more time, if you can hear me, guys, could you please give me a green check? Change check. Okay, great. So you can hear me. All right, this is going to be our 23rd lesson, my friends, the one before the last, and I'm sure you guys are excited. And talking about residential wiring, hope between class 24, guys, and 23, hopefully we will get you to know everything that you need to know about residential wiring. Before I go ahead and start, guys, how many of you do residential wiring? How many of you do residential wiring? How about a green check for yes, X for no? Other than like on a daily basis you do residential. There's a few of you who do commercial or industrial. Okay. So the question is, how many of you guys do residential on a daily basis? As part of your job description. Okay. It seems 50-50. If you do it for work, I guess you need to know how to do it for your own house, because you're, you're all required. If you're an electrician, you're supposed to do residential, commercial, industrial, bending conduits, bus duct. We can do it. Residential, my friends, Brenna, is kind of a special animal, and if you guys read the any sequence book, there's so many requirements, regulations related to residential. And my friend, there's one reason for this, of course, because safety. Residential wiring is in direct contact with public. Your wife and my children and your spouses and your significant others, and you shouldn't have any. So why the code put a lot of emphasis on residential, how to wire a bathroom, how to wire a kitchen, how to wire a basement, and so forth. Go ahead and start. I want a few reminders. Number one, I want to remind you that next week we're going to be taking our last class, guys, 24th on Monday. Can you guys give me a green check acknowledging that next week that will be on Monday? Everybody else give me a green check acknowledging that the class will be on Monday, not Tuesday. Everybody's over that one. Byron, my friend Dan. Next class is going to be on Monday, the same time. Okay, and it's going to be our last class, and then after that we will have an optional class to review for the final on Tuesday of the week after next week. Okay, just make sure. The second thing is I do not review the block exam, but if there's any question in particular you would like to discuss about the block exam that bugs you, I'm more than happy to go over it. But I've not received your results for the block exam. I'm checking my email here. So I review the block exam, as you know, because it's an exam. Any question guys about the block exam in particular that anybody is willing to say, Chad, go over question number 5 or 6 or 7? How about an X for no? I keep the answers with you because, as you all know, guys, it's an exam. Anyone is bugging you, email me or chat with me and say, Chad, question number 5 or number 6 or whatever. That makes sense, and I should be able more. Be happy to go over it and give you my 2 cents. So you can change your mind as we go through. So if there's no question about the block exam, if you guys remember last week what we did, we talked a lot about table 310.16. 310.16. I see Joanne's hand is up. I'm going to go past. Go ahead.
Homework due.
All homework is due by the last meeting, which is going to be that will be our review for the final. It will be the 26th. This was the last meeting.
Okay, thank you.
Okay, no problem. Thank you. Okay, thank you guys. A lot of you have emailed me your homework, and I acknowledge back that I received it. I collect the homework. I do not correct the homework, but if anybody is, because it's really easy to get them through the guys. If you have any question about certain ones, and some of you guys back to me about certain questions that actually in 2002 has not been updated, my apology. So if there's any issue about the homework, guys, that you can't find the answer, or the answer doesn't make sense, or the answer is not in the code because of a code update, please bring it to my attention, and I'll be more than happy to get back to you. Okay, homework. Thank you for reminding me when it's going to be last day of the 26th. That'll be the 26th Tuesday. So submit the homework. Also, all of you guys have given me all the homework so far, so we'll go on that one. Okay. Any other questions, guys, before I go ahead? Any questions related to the homework or anything else? Somebody next for notion so far, Chad? Go ahead. As we said, guys, we talked about table 3.16, how to use the table, how to create. We talked about a couple of other cables, medium voltage and low voltage cables. Test. The question is, when is the final test? The final test would be after it will be open Tuesday, April 26th, immediately after my review class. Tuesday, right? Tuesday, April 6th, immediately after the class, guys. I believe at 9 o'clock. After class, they open the exam for you. They open the exam for you, the 26th. Okay, thank you. So that's going to be the 26th. I will have review for the final, guys. It's optional. If you want to swing by, that will be great. I'll be here if you feel comfortable. It's an option. Okay, we talked, guys, about wiring. On the 16th tonight, we'll talk about residential wiring in particular. And I don't know about you, Joe, my friend, but believe it or not, wiring residential is more regulated. If I have to put my 2 cents, I would say 10 times more regulated than wiring commercial and industrial, just because of safety, and public are directly in contact with the electrical system and residential, right? And dwelling. That's where we sleep, we eat, and we do a lot of things in our homes and apartments and so forth. It's 4 times regulated. They tell you how many receptacles you want, how many receptacles you put in one circuit, we put the receptacles, and so forth. Okay, that's what we're going to go over, guys, tonight. And next week we're going to talk. We'll talk more also about continue to talk about layout, residual. I'll be more happy to talk about commercial industrial, but unfortunately, class is done. It's called residential wiring. As you guys go through your apprenticeship, you're going to have a lot of stuff about industrial. I don't know about you guys, but I don't know if you have checked my YouTube classes. I have 70 hours, 70 hours of YouTube classes, about NEC code book, electrical load calculation for commercial buildings, industrial buildings, Revit, using Revit and AutoCAD and estimating and so forth. If you haven't, if you like, check these 70 hours on YouTube. All what you have to do is just go Chad Kearney YouTube, and you should be able to see them and check all by Chad. And there's really good stuff there, some there. If you have a chance, check them. Okay, so that's with the residential. We're going to go ahead, guys, and start with our residential. A few things, guys, we're going to talk about tonight. Just emphasis, we'll talk about residential, which is 10 times more regulated than any other commercial industrial, believe it or not. Electrical service calculation and feeders. So we're going to talk about how to do the service calculation requirements and as well as the feeders. General lighting demand loads, how to calculate the loads for residential. A lot of you guys have done that if you went to technical colleges. I do have, Rana, my friend, an Excel sheet that I share with my design students at Dunwoody College. I'm more than happy to email to you when I show you, if anybody likes it. It has the code requirements and it has the math and map. I'll be sharing it with you tonight. Total lighting demand load, how to calculate the load, receptacles and lights and demand them and so forth. So that's basically the calculation in the first topic. The second topic is going to be grounding, again, for residential. So electrical grounding requirements, bonding jumper, grounding electrode conductor and so forth. We talked about then residential circuit power load calculation, the power, how receptacles and where do you put your receptacles and so forth. Number of circuits required based on a service load calculation for general lighting. How many 20 and 15 amp receptacles do you need for this building, at least based on the code, not based on the best installation, as we always know. Locations required for receptacles on light in residence, in dwelling units. So that's basically, so if I'm to summarize guys the whole deal, probably we'll talk about the service and the service demand. We'll talk about the grounding and the requirements for receptacles on light in a dwelling unit or dwelling units. So that's the topic for the night. For this, guys, I have a few things for you. I do calculations and NEC code book and so forth that we'll go over. Okay, so we'll start, my friends, with residential electrical service sizing. My friends, every time you hear the word sizing, and there is no better than Chad Kearney talk about sizing being an engineer. That's all the engineers do, the numbers, right? The single most important article that talks about sizing, Article 220. Article 220. Article 220. And you need to know about NEC calculation. Well, almost everything. I would say in 220 you probably find, let's say 70% of what you need to load calculation for residential, commercial, or industrial building. There's 30% you have referred to different articles. The 70% what you need is in Article 220, no question asked. Different locations, different applications, and so forth. A couple of things, guys. So what I do, guys, I'm going to go over a few requirements, and I'll share with you the NEC code book and go highlight a few things there just to remind you. I'm going to go size the service as well as the feeder. Again, service or feeder. Same calculation, feeder. And before I head, guys, and do this, I want to make sure that everybody understands the following: the difference between service and a feeder, residential or non-residential. So to help me do that, I want to start, guys, with let's just do it residential. Let's say we have an apartment, and the apartment needs a 600 amp service. My 600 amp service panel, guys. This is my service panel, right? Anybody has any issue with that? My service panel, and for my service panel, I'm going to go and install a bunch of circuits, different apartments in this apartment building. So my panel number apartment 1, here's panel apartment 2 and panel apartment 3, and as you can tell it's 4, and as you can tell it's 5. So which one is feeder and which one is branch circuit? Which one is service? That cable coming to your building, that's going to be, my friend, your service. Go all the way and circle the word service. That's power coming to your building. And everything else, as we all know, all these cables here going to different apartments, these are your feeders. These are going to be your feeders. Now, Gerald, my friend, if you're doing a house, 100 amp panel or 200 amp house, you only have service. You don't have feeders unless you have a sub panel in your garage or your shed, a 60 amp sub panel or 100 amp sub panel. That would be a feeder. Any question, guys, about definition of a service or a feeder? Any question about definition of a service or a feeder? What you're looking at in residential or commercial, that's really no different. These are looking at service, feeder, service, service conductors and feeders. Service conductors and feeders. And just to make things clarify a little bit, and then from here, if you guys take if you take a 20 circuit right in here, and you could feed your light, right? Like, let's say this is a bunch of lights, feed them from a 20 amp circuit. Now this conductor here is going to be a branch. That's what we call a branch circuit, right? So I say, guys, when I teach this topic, I say if you are in the electrical industry, the three most important circuits, and I believe I told you this before, the three most important circuits are circuits of the service the source circuit, the feeder circuit, as well as the branch circuit. So you need to be able to do the branch circuits. These are the loads from the last overconduction device to the utilization equipment, the load. This is from an overconduction device to another overconduction device, to another overconduction device, right in here, that's feeder between them. And the service is from the utility all the way into your service entrance disconnect means or overconduction device. Any questions about these three very important circuits before we go on? Any questions? We're going to be talking about sizing service and feeders in particular. Service and feeders. For service and feeders, guys, now we talked about this one. We have able for lighting and small appliances. Few things when we size it. The first thing we do is basic code book, and I'll show you guys the Excel sheet has all the requirements in any code book that they use. First, guys, and let me just go erase this one done here so you can see the first requirement. The first requirement from this table 220.12, get you the lighting, the general lighting loads, which based on this table, it's 3 volt amp per square foot. And my friends, only for residential. This also includes general purpose receptacles. Only residential. General purpose receptacles are included in this 3 volt amp. Only for residential, the general purpose receptacle is included. And that's very, very important, guys. If a commercial building, have volt amp that's just lights only for residential, and I can't emphasize this, it confuses the people all the time. When you do calculation based on the 3 volt per square foot, this includes receptacles, general receptacles, as well as general lights. Fully residential. If it's commercial industrial, it only includes lights. Anything guys about this? Very important to understand that general purpose receptacles are included in this 3 volt amp. Any questions? First thing is 3 volt amp, and I'll show you how the calculation goes in, guys. Okay, the second thing, so 3 for general purpose receptacles and lights, so you take 3 volt amp multiplied by the square foot of the building, and that will actually give you how many volt amps you need for this apartment building or this house. The second thing, based on code, the laundry. This always assume that the assumption is if you have a laundry, you always need and do 1500 volt amp for your laundry circuit. You have electrical dryer, gas dryers don't include that. If you have electrical dryer, it's always 5000 volt or nameplate, whichever is larger. Very important. Cooking equipment, we have table 220.55, and I have an example that we go through that one. And small appliances circuits, guys. Small appliances circuits in the kitchen, it's 2 circuits, at least 2 circuits, and each circuit will take 1500 volt amp. And friend, if you ask why 1500 amp, not 2000 amps, it's just really they have to do line between, what difference if it was 2000 amp versus 1500 amp. They have to draw the line between these circuits. So a 1500 amp on a 20 amp circuit, I guess that's a good chunk of load. If you have a fixed electric heat or cooling system, you get name value 100%. And I'll show you guys in the calculation Excel sheet that I have how all these are set together in an Excel sheet with the code references. Any question about this? Any question guys about this? Any? That's basically our load calculation. Before we and do that with the load calculation, I'm going to go, guys, before we get into the grounding, I will do 2 things: share my desktop, share my desk monitor too, and show you the Excel sheet that I told you guys about, and even do that one. I really would like to take you guys directly to the NDC code book. Okay, and with this, as I always, I split you guys so I can see your feedback right in here. nice dyslexia. And I also have, okay, we got your chat, so I see your chats here. That's about splitting you guys, put them on two screens. And polls and chat. We got the chat, we got participants, we got the participants said. Takes me a second to coordinate it, guys. Okay, here you go here again. And it is okay. Let's see videos. And then I take your video, Gerald, my friend, so I can see you. Now I can see you on top here. And right in here. Okay. All right. When it comes to the load calculation, and I don't want to make a load calculation nice, but I'm going to remind you guys, the first thing you need to know is Article 220. Commercial, industrial, residential, anything. And for those of you who do commercial, industrial, guys, oops, where am I here? We have a really nice sheet, Excel sheets that we do for commercial and industrial load calculation. So, I should be more than happy to share with you. Okay. The first and the most important thing I want to emphasize the feeder and the service calculation, and also branch circuit. So this is your calculation article. No question asked about it. It talks about the branch circuits first, how to do branch circuit calculation, then it moves to the feeder. As you guys can see, it moves to the feeder in two locations. Number one, it does the feeder and the farm dwelling, but this is the most important one right in here. There is optional. We go to optional if you want to, but I personally always use the standard method. And also the neutral, you can derate the neutral. So you can do calculation for feeder and service under part 3 and the neutral. So basically these in farming you go to the farmers, but these two are the most important ones, at least in my book. Go this one. So that one, and then here is the also it refers you, Gerald, my friend, to other articles that you have to go. Oh, by the way, here's a bunch of other articles you have to go and consult as you go do calculations. For example, air conditioning, you have to go to Article 440. Motors, it takes you all the way to 430. If you are doing single-phase converters, it takes you to 55. Solar system, 690. 2 storage batteries. So it's a different articles, guys, with very different calculations that you have to be aware of. So it's really a good reminder that not everything is in this article. All right, here's the table that we talked about. I make sure that everybody knows how to use this table. Since we're doing residential, guys, you're going to go to dwelling. Can you guys see dwelling over here? And if you go dwelling, and dwelling you should start off with a 3-volt amp. Here's my volt amp. So, for example, if I have a 10,000 square foot apartment building, 10,000 square foot apartment building, and multiply this one by 3, then your total volt amp is going to be 30 kVA for this building. That's how we use this. I want your attention, guys. That little what is it? Color here, or A? That little A here. This is where it tells you for real only. This includes receptacles as well as light. Receptacle as well as light. Any question? Can you give me an X, or has any question about that? So that's how to use this table. No gimmicks in it. Nothing. Question, my friends. So that's so that's the table. The most important things in this table. Move on, guys, into other loads, specific loads. Oops, 220. I don't want to go to farm. I went too far, Chad, too far. Where did they go? There we go. The 210. Oh boy, that will be an interesting situation. We don't go to 210, Chad. Here you go. So branch circuits go all the way to the feeders. Okay, so we found the 10. Then the second thing I want to go over, guys, is the demand. There is a demand table. After you calculate this demand table, is very interesting. After you calculate your volt amp, here's for dwelling. The first 3,000, you leave them alone. Anything higher than 3,000 up to 20,000, cut them by 35. Anything higher than 20 120 carried by 25 again. First one 35, the second one 25, and the first 3K leave them alone. This is called demand factor, guys. Very important to apply the demand factor. I'll show you in the test in the and it's a good place for it, but I'm going to make it, if we make it, suppose guys you have 100, let me just give you an example. Suppose you have 150 kVA for an apartment building. Suppose you have 150, you calculate them into 150. So what's telling you, anything higher than 120, so what's more than 120? That would be 30. Anything higher than 120, multiply by 0.25, right? Here's a 0.25, okay? You know that the 30 is more than 120. And between 3 all the way to 120, so that will give you 117, 117K. Divide these by 35, and the 3K, leave them alone. Can you guess how this goes? And add them all up. So 3K, multiply them by 100%, up to 117, 35, multiply 35%, which is 0.35. And anything higher than 120, multiply 25, 0.25. And then find the demand. We talk about the demand load for dwelling unit. The demand load for a dwelling unit. This is if you have a big apartment building, that's exactly how we do it. They have the same thing for hospitals, hotels, motels, and warehouses, or other loads like a commercial industrial building. You do not demand the lights at all. You don't demand the lights at all. And about this table, the demand table. Any question about the demand table? And about the demand? See your demand table. So let me go take a snap of that one and input it. You can see it could get involved, and then you get here and they get you how to show windows. For example, show window. Let me just go here for show windows. You 100 volt amp for linear feet. So how many feet? 100 feet multiplied by 250. That's your demand continuous load. If you have track light, can you see that? Track light, 2 feet, 150 volt amp for every 2 feet of a track light. So do your math on that one. Receptacle for dwelling. This is not for dwelling, so that does not apply for dwelling. The receptacles other than dwelling, guys, the first thing K, 100%, anything 100K, 50% again. This is for non-dwelling, this one. If you fix electric space heater, guys, remember that fixed electric space heater, the volt at 100%. And the laundry, small appliances, can you guys see small appliances circuit? Dwelling it, you need 100 volt amp for 2 circuits at least. Laundry circuit, can you guys see where the laundry circuit? It says 2. You need only 1 circuit. You need 1 circuit for it shall be for each 12-watt circuit as covers this load. So it's 1 circuit here and 100 volt amp. Any about these? Everybody can see where these are. Any question? Any question, my friends? Information that I was showing you can be, and let's move on. Oops. This is another one here. Okay. So on, guys, into, so you can see how all the calculation that you need is here. We talked about laundry, dwelling units, appliances, appliances load. Appliances load, guys, this little things fixed in place, we call them, shall be permissible to apply a 75% demand, blah blah, for 4 or more appliances fixed in place. If 4 or more appliances fixed in place, you can add them up and multiply them by 75, more the rates. Remember the electrical dryers? Electrical dryers, if you have an apartment building with multiple electrical dryers, so for example 10 of them, multiply the nameplate by 10 and cut them by half in an apartment building. for this building. Moving on to the range, to electric range. Here's how the range, guys, and range calculation without getting into too much angle on the range calculation. Let's just make it very easy, very simple. Suppose you have 10 ranges. Each one of these ranges, 10 of them. Each one of these ranges is 9 kW, which is equivalent to kVA. So 10 of them. Can you guys see how 10? And since they are 9, they are more than A, more than B. So they definitely under C. So demand factor for 10 of them, guys, is 25. So these 10, when I demand them, they're demanded as 25 kW. And the most confusing things, guys, is what is the demand, Chad? What is the demand? So for if you multiply these guys by multiply 10 by 9, get you 90 kW. Can you see, Gerald, my friend? Can you see we went from 90 kW all the way down to 25, all the way to 25 in residential. And the reason for this, because what's the likelihood? You have 9 apartments, all of them are using their range full gauge, every single eye, every single oven, every single cooking cob on this range is fully gauged at the same time. The 10 of them, you're going to probably, Gerald will say that's Thanksgiving, Chad. The likelihood of all this, guys, is very young, and it's a chance that we can take, and that's why they came up with the 25 kW. The 25 kW. So I don't have to size for 90 kW, and my service will be huge. My service will be huge. They demand all the way to 25 kW. Again, the range has a different calculation. So if we're 10 of them, suppose we have another 10, and in terms we're 8 kW, guys. There's another 10 8 kW. These 10 apartments. Here's my 10 8 kW is under here, and then I have to cut them by 35. So what you do, and you take the 10, multiply by 8, that will get you 80, and then by 0.34. Your demand. You cut by 0.34. And if you do the math on that one, you take the 80 times 0.34 equal 27. So that will get you at 27 kW demand. So I mean, Chad, when I size my feeder for the apartment for the service, feeder or service, depending on how the system is laid out, only to account for 27 kW. 27 kW. Anybody has any question about that? The range calculation? Any question? Range calculation, guys, have a whole lot of issues. If they're all below 3 kW, then you apply this column. If they're all between 3.5 all the way to 8 3/4, you apply this column. If they're more than 8 3/4, you apply this column with some restrictions. Okay, that's basically use this one as your load calculation. Any question, guys? I see your chat. Anybody has any questions about that? So that relation, it goes there. Here's very interesting, and I don't want to go through the details, guys, on that one. I want to just remind you that there's a lot of rules, and I teach this one, Gerald, my friend. I teach you exam prep for the people who want to sit for the exam, and these notes here at the bottom are very, very important. So, example note number 1, over 1200 kW. If they're all the same size, then you take the bands under C and increase it by 5% for every kW larger than 12. If they are different sizes, with all these different sizes, you average them and you increase the average 5% for kW larger than 12. Anything less than 12, make it 12. Average them, then increase whatever average, how high the average is higher than 12. kW, the average is higher than 12. you increase your demand by 5%. Really cool, and I don't want to get into it. Sometimes based on this, they allow you to use B or C and use the one that gets you the more demand. Their favorites, branch circuit loads, permissible to calculate the branch circuit for one range. In according to this table, you can apply the branch circuit, or if you branch circuit load for a wall-mounted oven, blah blah. If it's two ovens and one cooktop, counter-mounted cooking unit, you treat them as a range. All this, guys, is for residential only. All this is for residential only in this case. Any, my friends, any question about these? Just a quick review of that table. Kitchen other than dwelling, you apply. If it's kitchen, McDonald's, for example, you add all the cooking equipment and you multiply it by, if you have 12 of them, you cut them by 65. That's not residential. Coincidental loads, guys. If you have heating and cooling system, you choose the largest of the heating and the cooling system. And one, guys, the neutral. For your neutral, you can get the neutral 70%, 70%. For following for ovens and ranges, and so anything in excess of 200 amps, in excess of 200 amps, they rate them by 70%. For ovens and ranges, wall-mounted ovens, blah blah, you can cut them by 70%. So these are allowing you to have a smaller feeder for the neutral. If you harmonic, you can do that. So no rating if you have harmonics. If you have harmonics. Okay. Question, my friends? Any questions? Any questions? So that I thought just before we go to the option, I don't want to go to the option method and confuse you, but I want to remind you guys, I use this one all the time personally when I the neutral, especially the permission. That one particular one for industrial. I use one all the time. Anything higher than 12, cut it by 75%. Before I leave this code, any question guys about this code? I thought just a quick review of this and non-residential, as a matter of fact. Any question? That's for the residential. The second I'm going to show you, my friends, is service calculation right in here. Anybody would like it, I'll be more than happy to share with you. Grab it here. Excel sheet that we looked, and it does all the calculation for you. For example, and make it quick, guys, because I don't want to make a calculation. If you look, here's the article. I'm sure you. Let me go make it bigger. Here you go, so you can see it. Single family dwelling unit. The square foot of the building, my building is almost 5,000 square foot. Multiply by 3, get you this amount, 14,000. Ignore this. This is just how many circuits, 15 amp circuits do you need. You basically take this, divided by 120, get you this amount, and divided by 5, get you 9 circuits. So 9 15 amp circuits to feed this lighting and small appliances circuits, 9 of them, based on the code. But this is the volt amp for general lighting. The next step, guys, is for the 2 small appliances circuit. This is apartment building with 4 apartments. So I need 8. Why 8? Because 2 times 4 is 8. So this is for the kitchen, small appliances for the kitchen. I need 4 because I have 4 apartments in this building. If I have 4 apartments in this building times 150, that'll get you 1,600. Then you add them up. Can you see that? Where you add them up here? You add them up. And then you apply the demand factor. Can you guys see that? How you take this minus this, give you this amount. The first 3,000, leave them alone. Anything higher than 3,000, cut them by 35. So that's how anything higher than 3,000 cut by 35. Then you add these two, and that will be the demand for this step. That will give the demand for this step. So first them up, then you apply the demand factor for them, and this demand from table 220.42. If you're interested in this one, my friend will be more than happy to shoot it your way. All in the map. I don't know if you guys see when I click here. Can you guys see right here at the top? This is map is done by Excel. Ranges. I have, for this project, guys, it's in a four apartments in one four quadruplex. I have eight kW units. 8 times 432. Then you take the 0.5 from table 220.52. That will get you a demand of 15. Can you guys see that? These are multiplied. And then for dryers, I have 4 dryers. 4 times 5 give you this amount and no demand because 4. For heating and cooling system, guys, I have 4 air conditionings for this 4 apartments, 4 of them. Each one of them is 4 times 4 kW. So 4 times 4 gives you 1600. Then you add them all up. Can you see how we add them all up? So total, after you add everything up, then you fasten in place appliances. I have a water heater, I have a sump pump, laundry exhaust fan, food disposal, dishwasher, bathroom, garbage disposal, microwave, furnace, pool heater. I have a pool heater for this apartment, believe it or not, and a pool pump. Add them all up, they'll get you fixed in place appliances. Remember, 220.52 says if they are more than 4, cut them 0.75. So I cut them by 0.75 because they're more than 4. As you can see, there's a bunch of them. Add them all up, and everything basically up to this point. And take the largest motor, and remember, the largest motor happens to be the pool pump, the largest motor. Increase 25% in it based on the code to Article 430. And add everything up, you end up with 100.8 kW. If you divide the service, Gerald, my friend, my service is 240. I end up with 42.1 amps, and guess what? My service for this apartment building is 450 amps. 450 amps could be 500 amp service. So you can have a 450 amp fuse, and then feed a 600 amp panel from it, or 500 amp panel. Question, guys. So here's, I came up with the size of my service, 250 amp for this quad, and this quad is, some of you guys might think, well, the ones who do residential, that's too much, yeah. But remember, this is they have dryers and they have ranges and they have a swimming pool in this apartment building. A lot of stuff. A lot of stuff. And then how to calculate the service. So that's service. And then you do the neutral. Can you guys see how you get the neutral here? Then you take the ranges, cut them by 70%, and get the ranges and the dryers. You cut them by 70%, and you take only the 120 loads, because 240 would not be seen by the neutral. 120. And cut them by 0.75, exactly like we did for the fit. Increase 25% on them. And my service neutral size, my friend, would be 245 amps for the neutral. Okay, you go start your conductor 600 kcm, 2 conductors, and to carry the neutral 240, I believe 4 hours could get you. So you have 4 hours and 600 kcm. Neutral for us, 600 kcm should, if I'm right, it should get you to carry a 450 amp panel. 400 amp panel. And then you get into here and sizing the EMT conduit, guys. You get into sizing, how to size the conduit for it. There's the size you end up with. I don't know if we did right, so don't look at this one really. 2 inches. I think 2 inches sounds like small for 2 conductors plus that one. I'm not sure about if we did that over here, then you end up, based on this, you end up with 2-inch EMT. But also conductors, guys. 2 conductors km and 1 conductor for us. So that probably be 3 phase, 2 conductors and 1 conductor for kcm. And conductor, guys, the grounding electrical conductor, you go to 250.66, and here's your size for grounding electrical conductor. Any question, guys? Any question? Interested, Gerald, in that one, my friend? I should be able to show you with any questions. So basically, how you can put all together in one sheet, and it does calculation for you with Excel. I will close that one and go back to my PowerPoint presentation. Okay, any question about the load calculation? Any question about the load calculation? There's so many sheets, my friend, especially residential. Residential, Joanne, my friend, and Joe, you have tons and tons of sheets how to do calculation for residential. For industrial, there isn't many. If anybody's interested, I have really nice couple of ones that we do for a server that can go as high as 4,000 amp switch gear, 4,000 amp switch gear. Calculate the process equipment, the air handling units, the chillers, the exhaust fans, and all this good stuff in a commercial building. One more time, any questions about the service calculation? The calculation? Same thing, guys, we did the service. I want to just remind you, quick remind you, we did the service. You can also apply the same calculation for the feeders. Here's my feeder for if you have an apartment building, here's the all panel at the bottom. The same calculation that Chad have just went through, guys, here. And here's my disconnect for this apartment directly here. The same calculation for the service here can apply for all these branch circuits, not branch circuits, for all these feeders. Same, except random, my friends, now when you do the calculation for this feeder right in here, you are only going to take into consideration the stuff that's fed from this particular feeder, not everything else. While when you size that, you take into consideration what's in apartment 1, what's in apartment 2, and what's in apartment 3. Basically, what I thought give you guys a flavor of load calculation residential. Okay. Then the second component here after that one is grounding. Friend Byron, we know how to size a service. Residential, guys, most of the time, Brenna, I all know, most of the single standalone dwelling, you can't feed it for less than 100 amp, as we all know. And big 100 amp is good enough for, if you ask me as an engineer, this would probably be good enough for up to 4,000 square foot. It really is. If you ask me. You have a bigger tub. It's good up to 4,000 thousand feet. But our people, guys, because they ran our room, they all go all the way and they say, oh, I want 200 amp panel. And the way you go for 200 amp panel because you need more circuits, really not more juice, but you need more circuits, 20 amp circuits. So these are for the most part, for most average homes, standalone, single dwelling, amp or 200 amp. Get into the apartments. If anybody have done apartments, does apartments, anybody has apartment building, have a green check for yes, X for no. Apartment buildings. If you do apartment buildings, now you can go for a riser, one riser that can go as high as 1,000 amp. You can have and even higher, 1,000 amp. Single or three phase, and feed from these, you feed multiple apartments, as we all know, a riser, dwelling riser. So that you can go high. So it was not only single family dwelling and two family dwelling. It can go all the way to the residential apartments and residential apartments. To the high. Okay, grounding. When it comes to grounding, Brenna, there are into all the grounding. You guys will study grounding if you come to one of my grounding classes. We go in details on that. What's the grounding? I want to make sure that you understand very, very important concept. Concept number one. Concept number one, my friend, is thing is grounding. The concept that's called grounding electrode conductor. Grounding electrode conductor is the one that takes the service, and let me just draw my service. Here's my 200 amp service. 200 amp service is my in neutral over here. And here's my ground, right? Can you see that, the ground here? And here's my neutral. You take ground to the grounding electrode system. This conductor here is called grounding electrode conductor. Electrode conductor. Very, very interesting. That's concept number one. Concept number two for grounding, without into the details, is main bonding jumper. This bonding jumper between the neutral at the service, guys. See how we bond the neutral? This is called main bonding jumper. Then sometimes, Brana, it's just a green screw that you bond the neutral to the ground. That's called main bonding jumper. Very, very important. Main bonding jumper. And the third one, so if you don't know this, you're confused. And suppose I have a 100 amp panel, guys, here. And suppose this 100 amp panel is fed from this 2 amp panel, right? I can do that, right? Okay, and then with this 100 amp panel, I need to, here's ground, again, is my ground, and here's my neutral, and I don't bond them ever in the second panel, but I need an equivalent grounding conductor, and that conductor comes over here. Now this conductor is called the equivalent grounding conductor, e.g. the equivalent grounding conductor. Equivalent conductor, guys, grounding conductor, basically the ground wire. And so another application for it, so I have, here's my 20 amp circuit going to a lighting fixture. This is light, is here, right? And with the light, you also have a grounding conductor and go all the way to the ground. This conductor is also called equivalent grounding conductor. Equivalent grounding conductor. The question is, I hate to make it, Joanna, friend, there are, what's the bonding in the transformer? There's 2 bonding jumpers. One is called the main bonding jumper. You do this one at the service. And the second one is system bonding jumper. That's the one, Joanne, that you do at the transformer of a circuit derived system. So if you have a 480 208 120 and you bond the neutral to the ground at the 208 120, that's called system bond jumper. System jumper. Oh, okay. So it doesn't work because today because the transformer neutral was not abundant. Oh, you're lucky if the light doesn't work. If you don't bond, and I hate to make it bonding grounding class, if you don't bond the neutral, and if the neutral is for what reason disconnected, you can burn the building literally because you neutral and everything is shared between the 240 or the 480 or the 208 system. So neutral, if it's not bonded, is a big deal. So without further ado, guys, it's not enough completely. You're absolutely right, because now you have a single phase or 3 phase. You're sharing, if the voltage is 240 and 20, for example, and all the lights are sharing the 208. So they're going to be, and if you turn things on off, the voltage is going to change, and the light is going to be different. So make sure neutral is always bonded at the service and at every service derived system. Oh, so the grounding electrode conductor, guys, main bonding jumper, and equivalent conductor. Any question about these? Any question about these? Because if you understand these, good luck understanding the grounding and bonding. I mean, there's no way around it. So we have main bonding. This is the service. I want to bring to your attention. This is my service here. Service, inverter, and this is my sub panel. And this is, I'm showing a 200 amp. It could be 2000 amp feeding a 1000 amp. The same way. Ground conductor, equipment grounding conductor, and main bonding jumper. There's a few other things I want to leave them for another time. Moving to the grounding, the question comes to mind, guys, why do we ground system? I have this question all the time without turning it into grounding. Why do we ground system? We ground the system. And by my friend and Brennan and Joanne, is there's a big difference between a grounded system is grounded and providing an equipment grounding system. For example, let me show you this. If you have a system like this, guys, and I always emphasize, a system grid, here's phase A, and here to do that, phase A, phase B, and phase C. Is this system grounded? Is this system grounded? Avoid no, and here's the frame here, and the frame is going with the ground. Can you guys look at this and tell me, is this transformer grounded? Is this system grounded? Is this grounded? Can you guys tell me if this system is X, no, green, yes? Look, see, is this system grounded? There is a conductor here, right? The system is not grounded. When we say grounded system, that we mean one of the phases or the windings. For example, if I go right into the middle of this winding and take it directly to my earth, the system is grounded. Okay, another example here. Here's a delta. Here's a Y, for example. Y, you guys are familiar with the Y, and I hate to go to three phase because it's easier for three phase. A, B, and C, and I'm going to go to my transformer frame. Here's my transformer frame, and I'm going to go to my tie and take this one as a equipment grounding conductor ground. This guys, is this system grounded? Is this system grounded? Only this system is grounded. This system is not grounded. Why? Because to make this system grounded, you have to go to the center here and take this one directly to Mother Earth. Mother Earth. Now this system is grounded. Can you guys see what the word system grounded? You have to take the windings of the transformer to Earth for the system to be grounded. Just because you have an equipment, a grounding conductor, that does not mean the system is grounded. This is an equipment conductor. The system is not grounded if you only have an equipment grounding conductor. You have to take the winding directly to Mother Earth, like you can see. Okay, question about this? Because the most confusing things when people talk about grounding. Okay, when you hear the word grounded system, now you understand what a grounded system is. We're talking about this, or we're talking about this. Or if you have a system like this only, a system all like this, and phase A, phase B, phase A, phase B, and phase C, and from the frame, you took equipment, a grounding conductor. This system is not grounded. This system is not grounded. This system is grounded. Nothing is tied to Mother Earth from the transformer winding. Okay, so that we're talking about grounding system shall be connected to Earth and that. Well, why do we connect them? Look at the reason why we connect it, because limit. Look at the word. A lot of people don't understand that one. Limit the voltage imposed by lightning. You have lightning hitting the transmission line, transfer a huge amount of pulse that goes from here to the Lord and come back within milliseconds, and that burn your electronic equipment. To minimize this, we ground the system. That's number two. How about line surges? You transfer transmission lines from one to another, and that pulse that goes from here to the Lord and come back and get into your house and burn your equipment. That's a surge. Unintentional contact with high voltage. You have a high voltage line, guys, at the top of a low voltage line, it snaps off and it drops at the top of low voltage line and none of them is insulated, so you have an imposed high voltage on a low voltage line. This high voltage goes right through your house, and guess what? Your plasma TV is burned. So if the system is grounded, it will minimize it. And these are the reasons. And the last reason, stabilize the voltage to earth. That 120 that Joanne was talking about, that we love and we burn equipment at, or the 277 if we're doing commercial, 277 guys, to ground, to ensure that it is a 120 or it is a 277 all the time, we ground the system. Actually, that's why we ground the system. System, not the equipment, the system. I see anything that talks about safety here. Grounding the system is not, well, it is in an indirect way for safety, really for the system to work, work properly, and not burn equipment. I guess you can think of burn plasma TV as also a safety issue. Really, for the equipment to work properly, we ground the system. Equipment, electrical system grounding. Would require, I believe, anything higher than 50 volts to be grounded. If you have any system higher than 50 volts, you have to be grounded. Those for industrial application, they allow you guys to use an ungrounded systems. So, to case connection on the load side of the service, as we know, we just talked about guys, in a service, if this is a panel, you need to tie the neutral and the ground together in the you don't do it in the panel. This is violation. You have to do this only. The neutral and the ground are bonded together only at the service. So can you guys see that, where we only bond right in here, and we go to Mother Earth right at the service. You bond again here. You don't bond again here. And the reason why they don't bond again here, guys, if you bond twice, guess what? The neutral current will be going back. So short, Joanne, my friend, if you bond twice, who cares, Chad? Why can't we bond twice? Well, if you have, suppose you have, well, let's look at this circuit. If it's a multi-wire branch circuit, okay. Suppose you have, just say this is a multi-wire branch circuit. Say there's 10 amps here. There's also 15 amps in this one. Okay. The difference between them, guys, is 5 amps. The 5 amps, 2.5 is going to go through the neutral, and 2.5 is going to go through the ground. Times. So the equipment grounding conductor, if you bond right here, will act as a neutral conductor, and it carry current all the time, unbalanced current. Of course, that's safety hazard. We don't want that to happen, so that's why we bond only at the service. Any question, guys? Action, my friends. Okay, talk about electrodes. Let me go ahead and give you guys a break and give it 7:03. Let's go 7:07. So let's get you 7:08. We'll be back in 7:08. guys, you can check him, please. Thank you, my friends. Let's go ahead and okay. So before we go ahead, guys, I want to remind you that now we talk about the grounding electrode system, and this is exactly what we meant to write in here. So we are going to talk about this particular baby in particular, right in here. Okay, that conductor and going to Mother Earth. This is in particular what we're talking about. Grounding electrode conductor. That's not the main bonding jumper, just to see where we are in perspective. Okay, grounding electrode systems. So by code, you have to have something called grounding, at least one grounding electrode system. And the code guide 250.50 clarify what are the systems that qualify as the grounding electrode system. Here's one of them. It's an underground metal water pipe that you can tie your grounding electrode conductor to and tie it to the ground bar in the panel. That could qualify as grounding electrode conductor. Or you can tie it to the metal building or the structure metal with some requirements that you have to do. Or you can do the concrete encased steel. You have rebars or cover in a concrete encased cover or steel bars, and these are in direct contact with Mother Earth. That these guys can qualify as grounding electrode system. Or you have a ring or a ground ring around the building or a rod. Or if that's not enough for you, my friend, you can go ahead and use a ground plate. So the key point here, my friends, you only need one. Can you guys, do you understand that you only need one grounding electrode system? But your friend, here's catch 22 though. Here's catch 22. You only need one. So the steel of the building, if it's a steel built like in residential, it's not residential. Well, it's confusing a little bit. Say the steel of the building, you only need one. But if all the others exist in the building, you have to bond them to them all together. Sense, guys? You only need one, but the others exist, then you need to bond them to the system. For example, if I have a commercial building and I have the steel, the structural metal of the building is tied to the ground, and that's a good grounding electrode system, that's all I need. But if I have a water system come to my building, I need to bond to it. Or if I have a concrete foundations, I need to tie to them. If I have a plate, you do the plate. So if I have a water pipe, I need to tie to it. Okay, we're going to this one, Byron, my friend. So you only need one. Catch 22, Byron, and you just got that one. Actually, it's 2011 and 2008. Catch 22. If that particular one was a rod, if it was a rod or if it's a rod or round plate, if it's a rod or a plate, okay. I'm sorry, if it's a rod or a pipe, a water pipe, it's a pipe or a rod, then you need to supplement it with another one. You need to supplement it with another one. In residential, guys, here's my 200 amp panel and my ground. Here's my neutral. I'm just interested in the ground. Come over here. Here's my water system coming to my building. Okay, now this is I tie to my water because it's a pipe. I need to supplement it with another one. So when you go supplement it with a ground rod, all the way with a rod. So the supplementing, guys, you can supplement it with a ground rod, right into the earth. So either a ground rod or a pipe, a ground or a pipe. So if you have a pipe or you have a ground rod, you supplement it. Any questions about the supplement with a ground rod or a pipe? So the supplement you need is a ground rod. If you have a ground, you have to supplement it with something else, and be a pipe. Or if you have a pipe, a water pipe. This is a water pipe, and this is my ground rod over here. If one of them, you have to supplement with another one. That's where the confusion is. And this is in 2008, my friend, too. But look at this one. If you have a concrete encased, concrete encased rebar, my rebar right here, my concrete. Oops, okay, the color here. If I my concrete encased rebar here, and I tie it directly to here, then I don't need a rod. I don't need a pipe. But if the pipe is there, they have to tie it. So you can see the catch-22. You only need one. But if everything else exists, you have to have it. And you have a pipe or water, they have to supplement with another one. And you guys with this, that's why in residential, most of the time, all the time, we end up with a rod and pipe, right? Because that's the most in Minnesota and a lot of states. This is the most common electrode that we have in a dwelling unit. Is a rod because we can drive a rod, and a pipe because we need water. Most of the time, metallic water coming to you, and they're changing now. But if it's water coming to you, then you can tie to them. That's what it's two, because there's one supplement the other. 11, guys. 2011, they changed slightly the language. They said if you can prove, so you need two, unless you can prove to the inspector then that the impedance, the resistance to ground is less than 25. So about you guys, but you have to have a machine. So if I want to go argue with the inspector, here's my pipe here, and I want to say, well, okay, I have my ground here, and I'm going to tie it only to right here. I need one. If I can prove that my resistance of this system is equal or less to 25% ohm, then I need another wire. So I don't know you guys, how many of you have carried a resistance measurement for ground resistance measurement where you can measure it? If you can prove to the, well, at least you can prove that the resistance is equal or than 25, then you don't need another rod or pipe. If you can, which I don't carry equipment to measure it anyway to prove it, then you have to go and add another pipe, or it's residential here, or it could be commercial. You add the pipe. Any question, guys? So you the hook if you can prove, off the hook only if you can prove that you yeah, okay, and then anyway, so if you can prove that you can maintain the 25 ohms. Any my friends? So the electrode grounding system, among other things. So HL underground water pipe needs supplement. The next one needs supplement. A pipe or a rod. These two need supplement. Everything else is a standalone big boy. This is great. This one is great. Ring is perfect. Plate is perfect. The only thing I need supplement is the pipe or the rod. Pipe or rod. But if they exist in your building, guys, then you have to tie to all of them, as you can see. All of them have to be tied together if they exist in your building. Grounding electrodes. Grounding electrodes permitted. There's permitted ones. We went through a bunch of them here. There's 1, 2, 3, 4, 5, 6 of them. You guys looking at them right here. Underwater water pipe, guys, and here's some restrictions, and you can find this one directly from 250.52, guys. If you have a water pipe, they want it to be in direct contact with at least 10 earth for 10 feet or more. It has to be in direct contact with Mother Earth for 10 feet before you use it. So you're building over here, and you need a water pipe at least in direct contact with 10 feet. So for that, If it becomes non-metallic here, who cares? You got yourself the 10 feet the contact with pipe. Then you can tie to it as it enters your building. Question guys about the water pipe? Any questions about the water pipe? Water pipe needs supplement though. Remember, water pipe needs to be supplemented. Can't balloon. Second, which is well respected standalone electrode system, frame of the building or the structure. And they change a few. Input or more of single structure metal member in direct contact with earth or concrete in the earth. So you have to be in direct contact with or without concrete for 10 feet. Structure is bonded to an electrode. In 2008, they changed. 2011, they changed it slightly, guys. They said if you bolt the voltage to the foundation that acts as a ground electrode system, the structure is bonded to a ground rod having resistance 25 or less. Other means approved by the authority having jurisdiction. So that's open for the interpretation of the authority having jurisdiction. Anything else about this? So for the most part, especially in 2011, guys, if you still frame of the building, the beams in direct contact for 10 feet with foundation or without foundation, in the contact with 10 feet, you create a ground electrode system. In case that's the foundation of the building, guys, if you have a steel rebar limitation larger than half an inch in there, and if you can't maintain this, they allow you. They say, okay, no problem. Why don't you go stick a number 4 cover conductor in that foundation? Say the grounding. It could be your ground electrode system. The subsection, the length have to be 20 feet, and have to encase it in 2 inches of concrete, and the foundation has to be in direct contact with Mother Earth. For example, Joanne, my friend, you have a beam that's sitting on the 14th floor in downtown Minneapolis, and that beam has a rebar in it in the 14th floor. I can't use that beam as concrete encased steel because it's in the 14th floor, not in direct contact. So the only beam that I can use, it has to be in direct contact with Mother Earth, as you guys know, because that's where the moisture is, in direct contact with Mother Earth. So right foundation, surrounded by the foundation. So that beam, the concrete encased electrode, is the one that I'm trying to tie to. And guys, about concrete encased electrodes. Encased electrodes. Concrete encased steel or electrodes are one of the best electrodes that you can get, guys. If you have concrete foundations with we put all these rebar, you tie them together. In 2011, allow you guys to that 20 feet, allow you to have segmented. So here's 10 feet, and here's another 10 feet. So and these are tied together rebar. So they don't have to be one continuous 20 section. It could be different sections tied together with an approved methods for the rebars. Exothermic or actually rebar ties also are approved. So this is one of the best ones that gets you a low impedance to ground and a good one. Encased electrode, you guys can see that one here, and you're going all the way to Mother Earth water tube, and also as long as we go jump meters, so for services and so you can jump, take the baby out of service, and you still have a grounding electrode system. Any questions guys about the grounding electrodes? As you can see, guys, there's so many ways of finding that grounding. The idea, Brenna, is you need to be able to find direct contact with Mother Earth. The contact with Mother Earth, you can't just go through a wire in the ground and call it a day. There's some restrictions. How do you get direct contact with Mother Earth? So as you can see, we have the rebar concrete encase, we have the steel of the building, we have rods. All these these guys is to give us ample amount of connection with Mother Earth. Okay, that's not enough. You can put a ring. With the ring, you need a 20 foot of bare cover, of course, not aluminum. And the size is 2 or larger cover. You can't just put number 6. Serving as ground electrical conductor. It has to be buried at least 20 feet below the surface. And for the ground, it's not required to be larger than. Okay, so that basically we're the wire. Here's your building. We did these a couple of times, guys. You building and you have a ring. You can round your building with a ring, and you tie and you bring it to the building, and that will be number what do you say, number 2, and that will act around that building. That's the ground under. Oops, that's the color to use. Okay, and baby is buried up to 30 feet inches in direct contact, and you're good to go. The electrical conductor does not need to be larger than the grounding ring. What I'm trying to say here, guys, is they're saying, oh, by the way, if this is number 2, then this number doesn't have to be more than number 2, regardless of what the 250.66 states. And as about the ring, another option for you to ground the system. Remember, we're grounding systems here, guys. To ground the system, ring. Here's the ground rods. We're familiar with the ground rods. Ground rods must have an 8 foot in contact with oil, and there's some restriction in the size and so forth. Underground systems, any metal underground system, guys. Underground tanks, for example, underground metal well casing that's not bonded to the mineral water pipe, because if it's bonded, then it's part of an equivalent of conductor can be used as a grounding electrodes. To have a well, a metal casing of a well that could be in direct contact with Mother Earth, could act as if you are to guess, Jacob, my friend, what is the grounding electrode system? Is a metallic object in direct contact with Earth for direct contact with Earth, basically. So you take one of these metal buses and you bury that baby underground, I guess. If it's out of steel and you tie it, that probably will qualify under certain circumstances as a grounding electrode system. Okay, metal underground must be sized, and all the sizes are based on 250.66. When we sign, guys, we go to 250.66. How many of you have used 250.66? How many of you have used 250.66? Correct, yes. X, no. How many of you have used 250.66? This is an interesting table, and I'll put it in a second here. 250.66. Okay, so that basically now we know the ones that we can use. Now let's look at the ones that we cannot, shall not, will not use, not permitted. Gas pipe, metal gas pipe. I can emphasize the word underground. If the gas pipe is gas overhead, it does pipe overhead and could be energized, you have to tie to it if it's overhead. That's bonding. You have to bond it. That's overhead. Now the same gas pipe, if you have gas pipe that's coming to your house and entering the house right in here, then this is bringing your neutral, your grounding system. Here's my ground. This is called a no-no. You can't do that if it's underground. If above ground, you have to bond it. Bonding it above ground, guys. This is underground. This is Earth, Mother Earth, right in here. This is above ground. Any question, guys, about bonding above ground and not underground? You can't use a metal gas pipe underground, and you guys can understand because any spark or arc around gas pipe and you got yourself a big explosion. That's like the one happened in South Minneapolis. I don't know if you guys saw that one big explosion in South Minneapolis a couple of weeks ago. That was a big deal. And aluminum, the reason why we don't use aluminum, I hope you understand, because you'll be able to find it after a couple of years. If you use aluminum underground, corrosion is very severe. here, and you're not going to find that aluminum after a while. It's gone. Any thing is what these are the only two places restrictions where you can't use a metallic object. It's a metallic object in direct contact with Mother Earth, but you are not supposed to use it as an electrode system. Installation. Okay, so we have rods, we have pipe, we have plates. Where practical, ground rod must be embedded below. There's a few things, guys, about the grounding. Embedded below permanent moisture level, must be free of non-conductive coatings, such paint or enamel. So they want some type of non-corrosive metallic object in direct contact with Mother Earth. For a long time. He's talking about, guys, the 25 ohm. When the resistance of a single ground rod is over 25, an additional electrode is required and must be installed not less than 6 feet. That's what my friend talked about. Not less than 6 feet. In 2011, guys, to say the following. They say, now an exception, you need, if you have a rod or a pipe, plate, rod in the pipe or plate, you need two electrode systems unless you prove that the resistance is 25 or less. No more than 2 rods are required if the resistance is still more than 25 feet. So there's that one. So you have here's your underground stuff, my friend, and you grab your rod. You put your rod number 1 here, and you didn't get you got water to your building, so you draw another rod. When you add the second rod, they don't want you to put them closer than 6 feet, because if you get this than 6 feet, it doesn't get you a whole lot of options. It doesn't reduce your resistivity. You tie them together, and then you all the way to the panel, to your bar in the panel equipment, grounding conductor. Excuse me. Any says about the rods? So that's in 2011. They change it. They say default is having 2 unless you prove that you can 85 or less. So they put the ball in your yeah, to make equipment to prove it. And how much are going to buy equipment to prove it? None. So you just tie to the 2 equipment. And even if these 2 are there, guys, you have to tie to them anyway. So it's not like you're the hook. If there, you have to tie to them anyway. Okay, and I forgot to mention the plate, guys. The plate is, please add the plate is one of these less than perfect electrodes that need supplement. Plate, rod, and a pipe. These are, I call them less than perfect electrodes. They need supplements. They can't stand alone by themselves. They can be a supplement to each other. A rod can supplement the pipe, a pipe can supplement the rod, a plate can supplement the rod or the pipe, and so forth. A rod can supplement another rod too, guys. But at least it needs something. Any question, guys, about the supplement? Okay. Into the service entrance, I wanted to. We talked about electrodes. I want to go back to my code and take the table just one time to table 250.66. Table 250.66. 250.66. There you go. Okay, let me take you quick to table 250.66, my friend. Electrode system, and we take one example for it, just one time little example. Share desktop, monitor 2, and there you go. And we're gonna go, my friends, and grab my code book from here. We're hiding. There you go. Here's the, and I'm sure a lot of you guys probably have used or seen it, but if you have not, please be aware of that. Let me just grab you guys and put you so I can see you. At least see your feedback. Okay. How to use this table? This is to size the grounding electrode system. Electrode conductor for AC systems. For example, how do you use this system? Suppose we see 250.66. Let's suppose that we have 216. We just use a system that makes a whole lot of sense. 225. Both guys have I have a 100 amp panel. Yeah, let's say I have a panel 250 amp. So both I have, I'm just going to use panel. I have a 250 amp panel, right? And 250 amp panel, I need to feed it from a conductor, right? And that conductor, guys, 250 amp. If you go to 3 to the 16, 250 amp panel, I can use it. 250 amp, I can use 250. I use 250 kcm, K and M. And then I need to go size my equipment on the conductor. Here's my ground. Here's my neutral. I need to go from the ground all the way to Mother Earth. So I tie to my ground right here. Okay? To my ground. Okay, how do you size the ground conductor, the grounding electrode conductor? The question that comes to mind is how am I going to size this conductor, my existing electrode conductor? Okay, let's look at 250. 250 goes between right in here. Can you say that? Over 300 and under 350. And the way I'm using cover, because if they don't tell you otherwise, you're using cover. If you cross-referencing again with cover and go all the way, and that conductor will be number 2. This conductor will be number 2. So my will be number 2. Okay? And as long as we're any question guys about this, how to use this table, you size it based on the service entrance conductors coming to the building. Any question? Any question, my friends? So that, let's go size, guys, the system bonding jumper in here. The system bonding jumper. It's called the main bonding jumper, as a matter of fact. Main bonding jumper right in here. One is called main bonding jumper. Same way, guys. Main bonding jumper, we size it the same way. We come here, go all the way up to here, and in this case, my bonding jumper will be number 2. Number 2. The only difference between the bonding jumper and the grounding electrode conductor is if you go higher than over for this number, then comes there's different calculation for it. Different calculation for it. You take 12% times the conductor size. Any question, guys, about this? Any question how to size the grounding electrode conductor? How to size grounding electrode conductor? Any question? I'll switch ahead, make sure that you guys with me. Okay, I thought just to on that particular one for you. As long as we're in here, guys, I also want to bring to your attention a lot of things here that, number one, that always, if are tying to a rod, a pipe, or a plate, you do not have to go larger than number 6. And that's why you guys always see a number 6 essential, because you're always tying to a rod or a pipe. You don't need to go larger than number 6. Aluminum number 4. Also connected to a concrete encased electrode, you don't have to go larger than number 4. Ground ring, connection of ground ring, don't have to go larger than the ground ring. If you guys remember, the ground ring was number 2. The source connection, blah blah, shall not be to be larger than the conductor used for the ground ring. So remember, ground ring number 2, you don't have to go more than number 2. So these are kind of special. A and B and C are kind of restriction, regardless of the table tells you. If you are tying to a rod a power plate directly to the rod, you don't have to go higher than number 6. And going to the concrete in case, no higher than number 4. And if you're going to a ring, no higher than number 2. And guys, any question if you see these and you say, well, why Chad, why aren't they using the table? Because of these exceptions. Because of these exceptions. Okay, so let's get out of here and back into my service entrance equipment. My friends, anybody has any question? Any questions before we move to the next part? So rounding electrode and the main rounding jumper, as you can see, from 250 to 66. The second part, guys, so we know how to calculate the service. Suppose I have, since we're talking residential, let's just say suppose I have a 200 amp panel, and the amp panel. Okay, when it's residential, to emphasize one little thing here, quick, especially when it comes to residential. I'm going to move you guys back into the code. When it's residential, there is a tiny little table. I'm sure a lot of you are probably familiar with it, guys. Table, okay, 10, blah, 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 310, 310.15. There you go. Let's go. This is for, since we're talking about residential, make sure you use it. Take advantage of it. Here you go. Where are we? The temperature correct. Here you go. This table is very interesting, guys. This is for residential only, and since we're talking about residential, it gives you a smaller conductor. Smaller. Still in 2011, they slightly changed the name. So look at this is for residential 120 single wheeling, single phase wheeling, feeders and services. So remember my 200 amp panel. My 200 amp panel, I can carry it with number 2. Go to 310.16. If you go to 310.16, you need number 3. So if this the same panel, guys, if it's in a non-residential, I need number 3 out. So it gives you a smaller conductor size. So that's the way. So this is, make sure you know how to use that. That takes you all the way, guys, up to number 100. So if your panel is 100, I can carry it with 400 kcm, kcm. If the same panel goes into a commercial building, 100 amp, 400 amp, just to give you the idea, I need 500 kcm. I need a 500 kcm, 500 kcm. If the same panel was to be installed in another dwelling. Take advantage of this very interesting table for residential only. It gives you a smaller size, guys. It gives you a smaller copper or aluminum sizes for service or feeders. And the way, this is not just for the service. So my panel is 400 amp panel here. Size is the service here. This is my service, and from here, if you go to 100 amp panel, it also is the feeders. So if I have 400 amp panel based on this, it's going to be 400 kcm, 400 kcm, and for the feeder, I can go get away with number 4. I can get away with number 4. 3 conductors, number 4. 3 conductors, number 4. Can even do it, and well, 3 conductors, number 4 is good. So we'll do it in notes. Okay, that table, make sure you know how to use it. Very handy, very interesting. Talk about residential, I thought it's worth mentioning. Before the table, anybody has any questions, guys? Anybody has any questions? Any questions? Okay, let me see here. Good. Okay, so let's leave this baby and back to where we were. So that's basically the thing and the sizing. Let's talk about Remember, we talked about service conductors. Service conductors are covered under Article 230. Everything you need to know about service conductors are under, and service equipment are under Article 230. Other conductors in the raceway, I can put in the same raceway. If you have a raceway here, guys, and you're bringing inside your raceway your so you're bringing your feeders, 1, 2, and 3 conductors coming in it. I can't go bring a feeder with us. So feeder, and you are my service. You can do that. So this way with feeder or branch circuit. So the conduit, the cable that contain the service conductors are sacred cows and shall not be used to clean or house the feet or branch circuits. So that's a no-no. Any question about this, guys? And the reason behind this, if anybody is wondering why, because service conductors are not fully protected, because the overcome protection device for the service conductors is done by the electrical utility and oversize their fuses because they don't want nuisance tripping, so they are not fully protected from a short circuit. And if you are to put the branch circuits with them, if there's a short circuit you know, if there is deterioration in the insulation and you have the service conductors touching the feeders and transferring power into the feeders direct through the direct connection, you're not going to have a fully protected system. So the fuse will not see it fast enough before you create a fire. Of buildings, conductor must be a minimum of 3 feet from windows or openings, and they can't be below. They have to be to the side. And we all know if you have a windows, or they can be to the side here, 3 feet, clearing it all the way up to 3 feet. 3 feet when you put your power lines. Clear it of your power lines. Vegetation and support. You have a nice pine tree sitting over here, thinking that you can put your power lines in it. You are dreaming. So I can't use, and some of you might say, not Chad, I can't use my power line, tie it from here, go from here. Oh yeah, by the way, bring a wire all the way underground here and feed it into the building. That's wishful thinking. You can't use vegetation. Trees cannot be used for support of overhead service conductors bands. Overhead service conductors bands. So about this, that's a few things for the service entrance conductors. As a matter of fact, you can't use feeders also for vegetation. The same way too. You have to use a pole, especially side poles and so forth. Overhead service conductors must maintain an 8 foot above the surfaces at all times and goes all the way to 3 feet. So if you have, here's my building, and I need to bring a power line at the top of the building here, I need to maintain an 8 foot all the way up to 3 feet of the building here. 3 feet and 3 feet. All 8 foot up to 3 feet of the building. Question, guys, about this? I'm going to bring to your attention, guys, in 2011 they had a change here. Just in 2011 they're saying if that is unaccessible, suppose that this building, that's 30-foot building, right? 30-foot building or 10 foot not accessible, there's no ladder there. They are allowing you to go as low as 3 feet here. So that's a change in 2011, believe it or not. So I can have the power line going right to the top of my house as long as I clear it by 3 feet. So in Minnesota, that's enough for the snow to be covering the power lines, basically. If you put snow at the top of your house, the power will be directly in the snow. 2011, they reduce it only unaccessible areas. And if I remember the word, so basically I went through the word non-accessible. that qualify non-accessible by elevation. So if you put a ladder to get into the place, that's not readily accessible. Not readily accessible. And you guys about this? Mention about this. For being 8 feet stands until 11. Point of attachment. The point of attachment for the surface drop conductor must not be less than 10, as we all know, guys. Power lines coming in here to your building in here, and here's my power lines. And you come over here, you're bringing it from the power lines all the way tied up to the point of attachment. You have to maintain at 10 feet. 10 feet. And there is restriction in how high you can go. The other is at least 10 feet from the point of attachment. But because the minimum service conductor length can be maintained. Finish, okay, 10 feet above the finished grade and must be located so that the minimum service conductor length can be maintained. Can be maintained. There's somebody else to go and put a deck here, right in this area, and then you are down to 5 feet. Down 5 feet. Must be located, and don't ask me how you're going to prevent the people from doing it, so that the minimum service conductor clearances can be maintained. You can't prevent the people from putting a deck in the back of the backyard. Well, supposed to. Okay, any question, my friends? Any question? Service drop conductor can be attached to the service mast, and we all know and we have seen, guys, how the low voltage, the coaxial cable go and they tie the mast is coming right in here. So this okay, it should be right in this area here. There you go. So okay, so here's my mast, here's my power lines coming from here all the way down, and then the low voltage guys come and they tie the low voltage line coming from here and they tie it directly here and bring it down. That's a no. Do that. Protection of open conductors and cables above ground. The service cable shall be protected from physical damage. Must be protected if you are coming, especially guys from you're coming from service lateral. So here's my power lines here. Probably have seen it. You're coming from. Here's my transformer sitting in here, tied to the power line, coming from the plane, going through all the way to the ground, all the way down to the building. As a ground, and if you go here, here's my building coming in here, and this is underground. You have to provide a protection up to, I don't know how many of you guys remember that, upwards have to be divided up to foot above and 18 inches below. Cables coming down, and for any feeder, guys, 8 foot above the floor, the ground, and 18 inches below as you bring your cables into the building. Any question, guys? Any question about this? To my friends? Basically, location readily accessible. Disconnect. This is for the disconnect, guys. With the power lines, I hope by now we all know, as you bring your power lines, you have to be connected directly to what we call a disconnect. And disconnect must have a fuse. So I have a disconnect fuse like this. That's then you download it, or like a lot of us do, instead of this, you can overcome protection device, a circuit breaker. So here's my circuit breaker. I have a disconnect fused with a fuse disconnect. So the disconnect means must be placed at the readily accessible location, either outside or the building or the structure, or inside at nearest point of entrance. That's interesting. As you guys know, here's my building over here. You bring your power lines in from above, or I guess it could be from above. or from below, my power lines coming in. The minute that you enter, the closest point disconnect will be located right in here, inside the building or outside the building. Then I can use a feeder inside the building or panel and so forth. So you have to disconnect, fuse, disconnect to protect out building or inside the building as close to the point of entrance as you can. Inspector guys, if you enter from one wall, they want the disconnect and the main service disconnect to be on the same wall. So you if your panel is right here, and you can't just bring your feeders from right in here. How am I going to do that one? You can't bring your book from here, go through here, and feed your panel. So you have to put your panel right in here as you enter on the same wall. Any question guys about this? Any question about this? As close to the service entrance connect for sense equipment as close to entering as practical. Few things about service disconnect, and I know we jump a lot. A couple of things that comes to my mind as for service disconnect is for residential, since we talk residential, minimum of 100 amp. Amp is minimum for residential. You can't a smaller than 100 amp service for residential. 6 amps for non-residential minimum with some exceptions. 6 for non-dwelling with some exceptions. Premium. The thing is for service disconnect. Suppose I have an apartment building, and my apartment has apartment 1, apartment 2, apartment 3, apartment 4, apartment 5, and apartment 6. Now, up to this, I can have my conductors tied without a main. So here's my switch gear, basically, or switch is panel. Can you guys see there is no main for this panel? Because these, each one of these would be the 6 disconnect rules. Remember the 6 disconnect rules, you can have 6 disconnect services grouped in one location without a main. The minute that you add a 7th one, say I add the 7th one here, then you have to now go and put an overcurrent detection device right here. So again, about the 6 disconnects, you can have 6 disconnects without a main. Who cares about this, Joanne? You can, and then my friend, you have a cheaper equipment if you maintain a 6 disconnect rule. So 6 disconnect, I can only have, I need a panel with no main. So if this was a 400 amp, saved yourself 400 amp circuit breaker here, which is an arm and leg. It costs you good money. You was directed to the switch gear. Okay, a few things about the service. There's exceptions where you can add monitoring. Yeah, there's some exception with it, but for the most, the 6 disconnect rules will get you there. 6 disconnect rules will get you there. So let me see power circuit before we get into the circuit. Okay. How if I give you guys a 756? Let's get you a quick break here, since it's a good time to break here. 56. Let's go 803. Let's back at 803, and then we'll continue with the power. you can check in, please, my friends. Right, let's talk a little bit now. We talked about the service and about the service conductors and the grounding and the feeders. We're going to talk a little bit, guys, about the branch circuits. In the NDC code book, I'm sure you know by now, if you go to Article 230, Article 230 gets you everything that you need about the service. If you go to Article 215, 215 will get you feeders, and go to Article 210, 210 you a branch circuit. So 210 and 215 is very similar, guys, but they're slightly different. So 3 different articles talk about 3 different circuits: feeder, the service, the feeder, and the branch circuit. So a little bit about the branch circuit now. We're talking about 220.10, as you all know, conductors. How do you size a conductor, a branch circuit conductor? You take a branch circuit continuous load and non-continuous load. You take 125 amp of the continuous load plus 100% of the non-continuous load. Example. So I want to size, let's do a very simple example, guys. I have a machine that I want to size it, and that machine has 10 amps continuous, 10 amps continuous, and also inside this machine there's 5 amps non-continuous. So how do you size a conductor for it? No problem, Chad. You multiply this by 1.25, right? The continuous one, and then you add the non-continuous to it. So give me 12.5 plus 5, and that means 17.5 amps. Okay, and 7.5 amps, continuous and non-continuous. You go to table 310.16, 310.16, and you go size it for number 12 conductor. So number 12 conductor. So I have number 12 conductor, and I size it based on the continuous load, 125, which is right in here, and the non-continuous load, which is only 100%. You go to table 310.16 and you size it. Any question, guys, about sizing branch circuits based on continuous load and non-continuous load, continuous load and non-continuous load? Continuous load, the continuous load is a load that can run at full load more than 3 hours, 3 hours or more. At full load, not load, full load. If you have a machine that can run for 4 hours or more at full load, then this is continuous load. When you use the branch circuit for it, you have multiplied by 1.25. Example of this, guy, is all air conditioning. All motors are considered continuous load. Capacitors considered continuous load. Lighting systems considered continuous load, and so forth. Branch circuits, others. A couple of requirements for branch circuits that I always like to mention. For a branch circuit, guys, you can't use this at number 14. Small number 14 shall not be used for branch circuits. The instructions as tabs. We can use them as tab conductors, or 10 conductors must have an impedance not less than 15 amps, rated blah blah, 40 amps. So as a branch circuit only, guys, from here all the way to the load, I can use this and number 14. This and number 14. But but you can tab them. You can tab number 14 conductor with number 16. They use them in fixtures, guys. If you have a fixture wire, you use them fixture wires. So for fixture wire, you can see 2 wires coming out of it, number 16 here, number 16, and they're tied to a number 14 conductor here. That's okay. Fixture wires, number 14. Branch circuit is number 14, number 16 fixture wire. So the different tab rules apply individual other than receptacle or tab not over 30 feet. There's some restriction, but a bracket shall not be less than number 14. And if that's not enough for you, that number 14 that you guys saw, the conductor number 14, has been there since the first code adopted, which is 1897. since 1897. National Electric Code 1897. That requirement has been there. And you've got more than 100 years. If you go to, I have a copy, I don't know if I showed you guys, I have a copy of the 1897 NEC code book. It's not special, Brenna, to have it. One of you guys can have it for $82 from National Fire Protection Association Library. Library of the National Fire Protection Association, NFPA. Library can sell it to you for $82 PDF file. So that's, I always think it's interesting. Now guys, for the overcome fiction device, when you size the overcome fiction device, the things for continuous, non-continuous. So back to my example that I've done, if I size the overcome fiction device right now, which right in from here, I'll go size my overcome fiction device. I came up with 17.5, the same calculation. You're going to take this one to 240.6. That's where you have the standard overcome fiction devices, non-adjustable. And to the next standard after 17.5 is a 20 amp circuit breaker. So for example that I just showed you, in this case you can have a load. Here's my load. You're going to have 20 amp circuit breaker feeding a number 12 conductor to feed a load. The load is, we say, the 10 amp plus 5 amp. 10 amp plus 5 amp, continuous and non-continuous. Any question guys about this? How is the conductor? How is the conductor and protection device? We size the conductor case that I just showed you guys. Here's my machine here, which will be, as I said, it's it has a 10 amp. So here's my 10 amp continuous, C continuous, and 5 amp and C for non-continuous. So sizing, as you guys have said, I came up with number 12 conductor, and number 20 amps. Now the thing would be, my friend Chad, how many of these conductors do I need? Well, tell me what the voltage. This system was 480, so suppose this system was 483 phase, right? Then I need 3 conductors. Suppose this system was 240, then I need 2 conductors. Of course. So this is the system. Okay, that's a continuous. Any question guys about branch circuits? Any question about branch circuits? The main thing for branch circuit sizing and basically continuous and non-continuous. By the way, Dan, my friend, the same continuous, non-continuous, this one and the one before here, the branch circuit, that one here, these threads are the same for the feeders. The same way for the feeders. Size feeders. Any question, my friends? Anybody has any question about this? Any question? Of that, guys. So we talked about branch circuits. We talked about feeders. We talked about service conductors. Talked about grounding, and the last part, guys, of this, we're talking about laying out outlets and lights, laying outlet boxes, receptacle and lights in residential, If you guys are not familiar with Article 21052, get familiar with it, because it will give you a lot of places, a lot of things in Article 220.52. Receptacle outlet, general, in dwelling. Remember, we're not in hospitals, we're all dwelling. A receptacle outlet must be installed in every, look at the word, kitchen, family room, dining room, living rooms, habitable rooms, like den, bedroom, recreational rooms, and similar areas. Basic criteria and a wall and floor receptacle. The criteria will be about. So for this particular one, I like always to flash a few things here. Let's go, guys, to the article directly, 250.52. So let's go to share desktop to 210.52, directly to 210.52. So if I have here, okay, all right, 210.52, 210. Again, that's 50. Where am I here? 250. Okay, is it 252, guys? 252 tells you where the receptacle has to be located. Actions I like to highlight in particular. So this is we just you guys were reading here. All these need the receptacle areas. Spacing. Receptacle touch no horizontally 6 feet rule. For all these, I call them guys 6 by 12. 6 by 12 feet. 6 from every opening and 12 in between. All these areas, you have to have one receptacle every 6 feet from every opening that goes to the ground and 12 feet in between. Very, very clear. Use bases. Any base 2 feet or more must have a receptacle. Any base 2 feet or more must have receptacle. Fixed blah blah blah, excluding sliding. So you have it. So the key is the 2 foot. I always emphasize the 2 foot. Space affected by fixed providers such as spiral bars. Okay, all these bases guys have to have. If it's 2 feet or more, you have to provide a receptacle. Floor receptacles. If you install floor receptacle, because you can put them in the wall, receptacle shall be installed in the floor, shall not be counted as part of the receptacle unless they are within 18 inches of the wall. So can a receptacle in the floor? No problem. Bring it on. As long as it's within 18 inches, it will count as a wall receptacle. It will count the wall receptacle. Receptacle always served in the kitchen. Then 220 amp circuit, guys. Remember, they have to be fitted from a 220 circuit dedicated for the kitchen. That's nothing shall be connected to it. In addition, requirements, blah blah blah. Switch receptacle supplies from a general purpose brand circuit. Okay, receptacle outlets for refrigerator. Always bring one receptacle for the refrigerator and so forth. Note that you can't feed anything from this. This is circuit out. There's exception, guys. We have an electric clock you can feed it from, and gas-fired range. 2 exceptions that they put them in the German exam. Can you feed anything from the 220 amp circuits feeding the kitchen? Yes, you can. What is it? Electric clock and gas-fired supplemental equipment and lighting on a gas-fired range. So these are, or cooking top. Maybe where we are here. Participants. Drag this and put you here so I can see. Anybody have any question, my friend? Any question about this? Basically, a few requirements that I like to mention on that one. So we talked about the kitchen equipment, floor receptacle, water outlets, kitchen equipment requirement. For kitchen, guys, really interesting. For kitchen, here's the rule that I use for kitchen. We'll look at them in a second here. For my rule that I always remember personally, I call it 2 by 4, 2 feet by 4 feet on the countertop by 4. So when you're countertop, every feet receptacle from like 2 feet from the edge you need receptacle and 4 feet in between. So top kitchen blah 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 shall be where the 12 inches. Okay, wall space. A receptacle shall not be installed. Each will cover about 12 inches or wider. Receptacle shall be installed so that no point is more than 24 feet. So that's where the 24 inches, the 2 by 4. And also, receptacle shall be installed at each wall counter that's 12 inches or more. 12 or more, one receptacle. The German exam, this particular one, guys, look at this one. If this exempt from wall line, if it's if less than 12, please remember this for your journeyman exam. If it's less than 12, and if it's kitty corner like this, if it's less than 18. What does it mean? If this space they took as an exam, they put right at 12. They see the distance here is 12. Then you start placing your receptacle. You go here. You your first receptacle. That's your 2 feet. And then if it's 12, then you continue. Out here, you put your second receptacle. That's 4 feet. And you keep going here. And up to here, it's 3. Suppose this is 3 feet, right? 3 feet. Then I need another receptacle here, because I have to maintain the no more than 2 feet from this side. 2 feet. Okay? So then does it count? And you guys about this 2x4, I always remember it as 2x4 on the countertop. Every foot or more, every 1 foot or more on, you need a receptacle at least. That's top. And please remember the 18 and the 12 is again for your journeyman exam. If it's 10, 18, you count it. What does that mean, Chad? That suppose that this one less than 18. Suppose that was 11 feet. 11 feet, guys. Then all I need is 1 receptacle here and 1 receptacle in this area. If it's 11 feet, no need for receptacle. Then when you make this one 12, then you need the receptacle. Then in this area, you need a receptacle right behind it. Any question about this, the countertop, guys? The placement of receptacle on the countertop? Questions? 18 here too. Like to specify island if you have an island, guys. An island, and these are all from the NEC code book, guys. Right directly here. Grab this. 24 inches by 12. So if it's 24 or greater, and short dimension is 12 or greater, then you need 1 receptacle. 1 receptacle. The same thing, guys. 24 by 12. 24 by 12 or more than 24 or more than 12, then you need a receptacle. Okay, receptacle shall be located above, and you can't, not more than 20 feet. If you locate the receptacle more than 20 feet from countertop, it doesn't count. It does not count. Bathrooms. The bathrooms, guys, as we all know, you need 1 receptacle. And 1 receptacle within 3 feet, and it has to be GFCI. Outlets, you need outdoor outlets in the inside shall be installed in accordance with E1 and E3. On a 1 family and 2 family dwelling, you need 2 receptacles, 1 in the front and in the back, above grade at least in the front and the back right here. And you can't be more than 6, should not be more than 6 inches, 6 feet 6 inches. Family dwelling, this is really interesting. A lot of people, guys, forget this one. In family dwelling, you only need it if you have an exterior entrance. It will exterior entrance at least 1 receptacle outlet from the grade. So if an apartment building and have an exterior egress door that opens to outside, then you need a receptacle in an apartment building. Only for the apartments that open directly to the outside. Sense. Balcony, my friend, you also need a receptacle. Balconies. By the way, this exception here, this exception is gone. This exception here is gone in 2012, so don't even look at it. The exception is gone. Now, any balcony needs a receptacle. Don't even mess around with it. In units, you need 1 receptacle for the laundry room, and we all know why. These are a few things, guys, to remember. Laundry room. You need a receptacle, 1 family dwelling in a receptacle, at least 1 receptacle in addition to any others. Where the portion basement is divided, you might need different receptacles. Hallways, a receptacle every 10 feet, receptacle for, if the 10 feet or more, you need one receptacle. So that's the ones I'm going to emphasize, guys, before we move away from the spacing in the wall. Any question, my friends? So as you see, the code goes in details where to put the receptacles in the dwelling units. Any questions? Any questions about this? So receptacles, don't forget that all the kitchen dwelling receptacles have to be fed from a 220 amp circuit. That's kind of a sacred cow called 20 amp circuit. Receptacle for countertop must be installed in accordance to the following. So in the kitchen, you need receptacles. Countertop, my rule is says 2x4. Always remember, I always remember it's 2x4, guys, in the countertop. 2 feet from every sink, from each of the countertop, and 4 feet in between. One thing, here's the receptacles. Remember that 2 inches by 1 by 2. If you have a kitchen dining area space wider than 1 by 2, you need a receptacle for that one, like a peninsula. The same thing, 1 by 2 or more, you need a receptacle, which is 12 inches by 24 inches. You guys remember that we talked about peninsula? Remember that term, 1 by 2, you need one receptacle at least. We're broken or separated, then you start counting again. You have a sink right in here. As we all, you grabbed your sink in here. That separation is my receptacle one here, because this is 24 inches over here. This happens to be, let's just say from here to here, this happens to be, this is 12 inches. By you need another receptacle here. And this is my sink. Right there. Or you have a fridge or something, so you need a receptacle here. Because outlets for the countertop space must be located at least 20 inches. To put them 20 inches above. If your countertop is, if you receptacle more than 20 inches above, so you have receptacle. You have your receptacle over here. It has to be 20 inches or less, or otherwise it wouldn't count. Otherwise it would not count. Okay, bathrooms. You guys remember what we said about the bathroom? One receptacle fed from a 20 amp circuit within 3 feet of a sink and GFCI. Always. I'm sure a lot of you guys remember that if you do residential. That's kind of like the alphabets of wiring. 20 amp circuit feeding one GFCI receptacle within 3 feet of a bathroom. Now here's a question for you guys. If I have a bathroom, here I have my receptacle here, and exhaust fan over here, and light here. So when I here, I want somebody to tell me if I'm doing right or wrong. I have a circuit from here to here, and I choose my switch here to switch the fan, 2 switches to switch the fan. And let's go wire it right. Okay, get this one. So I grabbed a power from here to power the switches. From switch 1, I went to the light. From switch 2, I went to the fan. And for receptacle, I went all the way to a 20 amp circuit. 20 amp circuit. Okay? All wires are number 12. All my wires are number 12. This is G, F, C, and I receptacle. It's installation right. Can I do that, guys? Can I do that? Can I bring a 20 amp circuit, feed the receptacle and the fan and the light? How many of you say you can't do that, and how many you can't? I say you can, you can't. See, a 20 amp circuit fit the receptacle with the feed. That's okay from the basin. And I also fit the fan and the light from it. The installation, guys, is okay, correct, no problem. Can I bring another circuit for the fan and the light? No problem. You can if you want to. where it becomes wrong. Suppose that I want to go have another bathroom, and I decided to be Chad Curdy, the greedy guy. Is another bathroom, and I have another fan and another light. Now I can't use the same circuit to feed the second bathroom. So that circuit, that bathroom has to, and here's my other two switches, another bathroom. Then you have to feed these from here, feed these from here, and you have another circuit, another AM circuit. So, okay, if don't feed the fans, if don't feed the fan and receptacle, why would you do that? But they allow you, if you don't feed them, they allow you guys to go from this receptacle to this receptacle, out of here to a 120 amp circuit. 120 amp circuit feed only the receptacles in the kitchen, in the bathroom. No, if you're feeding more than one bathroom, you only limit it to the receptacles. If you feed one bathroom, you can feed everything in that particular bathroom, especially exhaust fan and the receptacle. Any question, guys? Question about that? Any question? Bathroom outdoor, we all say as you two 15 or 20 amp receptacles. It has to be GFCI weatherproof. Oh wait, everything has to be outdoor weatherproof, GFCI tamper resistant, right? And one one at the front, one at the back. So you have a building here, the receptacle right in this side, and I mean single family and two family dwelling, one receptacle here, one receptacle here. Can I power these from the same circuit? May I feed these from, grab the circuit right in here, feed these, and here's one receptacle here, a grab receptacle, a third receptacle here, grab together and feed them from a 15 amp circuit. Is this okay? Is it okay, guys? And by the way, just to make it clear, this area here is a bedroom. So a receptacle in the bedroom and two receptacle in outside, and feed them from the same circuit. Is this okay based on the code, guys? Is this okay? I'm not, is this good? I'm saying, is this okay based on the code? How about green check? Yes. No, don't hesitate. Give it a shot. Nothing wrong with that, guys. There's nothing wrong with it. You know, you feed it. The only restriction is these receptacles inside were in the kitchen or the bathroom. Then do it. With that one, keep in mind that your receptacle have to maintain 6 feet inches. Laundry. The laundry, my friend, you have to have a one receptacle, 20 amp for the laundry, 20 amp, one circuit, one receptacle for laundry. The basement, at least 150 or 20 amp receptacle outlet installed in each garage, or each detached garage with electric or basement. So you have these are, if the detached garage is powered, then you have to have a receptacle in it. Attached garage, you must have at least one receptacle, GFCI, weatherproof, GFCI tamper resistant, GFCI tamper resistant. Regardless of how big the hallway is, my friend, you can have a 100 feet hallway. All you need is one receptacle. We have a 10-foot hallway. All we need is one receptacle. Here's a 10-foot. Regardless of the length, as long as you have 10 or more. If I have a 9-foot hallway, you need 0 receptacle by the code. Now, it's the idea to put a receptacle in a 9-foot hallway. I think so. If it's my house, if it's yours, Dan, I'm not doing it unless you pay me for it, right? If you bid this job to code and you're a 9-foot hallway, I'm not going to put a receptacle because the code says 10 or more, right? But we do business with people, guys. If the owner wants you to put a receptacle, would you pick a fight with the owner over a receptacle? I wouldn't. GFCI will not work on an AFCI breaker. Well, where I said we need AFCI, I didn't say AFCI arc fault circuit interrupters, guys, are almost needed in places where you don't need a GFCI. Where you need, I think I see what you mean. Maybe you meant when we went down here. You need, this is going to be an arc fault circuit interrupter by code. Why? I've never heard that the GFCI doesn't work with the AFCI. Certain equipment doesn't work, but can I feed a GFCI receptacle from an arc fault circuit interrupters? I don't see not. And if you guys have seen, probably and haven't had any issue with that. Normally don't, but can do it, yeah. Any issues with like a receptacle for GFCI receptacle from an arc fault circuit interrupter? I haven't heard anything. Do we need to? No. The circuit in the bedroom must be, you're absolutely right, my friend. The circuit in the bedroom, the circuit has to be arc fault circuit interrupter. And the arc fault circuit interrupter is required, guys, almost in every dwelling area that's not a GFCI. Excluding the bathroom, excluding the kitchen, exclude unfinished basement, garage, outdoor receptacles, attic. So these are the places excluded from arc fault circuit interrupters, including everything else, all the lighting circuits and receptacle circuits in the rooms, hallways, bathrooms, basements, dining rooms, whatever habitable room that you have else. Okay, question is, any question, my friends? Any question? Any question about that one? Okay, move into the wiring. Now, wiring residential, my friends, wiring residential, the single most important, we talked about ROMIX, guys, the single most important cable that you're going to be using in residential is NM cable. Use it 95% of the time. Non-sheet cable, if it has a B, it stands for 90 degrees, meaning the insulation inside it is 90 degrees. Framing law must be, just a quick reminder, guys, because that's the most important wire method, at least in Minnesota, that we use. Okay, could not get GFCI to reset down. Okay, that's interesting. Never heard of that one. I do a lot of training for contractor. I've never had anybody complain about them. And people put GFCI in arc fault circuit interrupters. Again, the only situation is like the one that I've just showed. If you're outdoor receptacles, and let me on that one. That's interesting. Arc fault circuit interrupters not working on equipment, like an old fridge will trip them. Fluorescent light will trip them. Certain things, so people not. Some loads act as an arc by the way they consume, digest electricity. They just in a signature of an arc. So that I heard of. Okay, that's a good one. Let me check on that one. Wiring, guys, we all know if you're going and install through or parallel to framing, you have to maintain 1.25 inches. You guys remember we talked about this one when we talked about wiring long time ago. We said you have to maintain 1.25 inches, and that's just for 25 inches, 1.25. 1.25 inches. That's for the sheetrocker, so they can't cut, the screws can't cut through that cable. Bend, and this is just a quick review, guys, since we talk about residential. You can't bend it 5 times, less than 5 times diameter, because that will be insulation. Be secured. When you secure, guys, we have to secure 12 inches and every 4.5 feet. 12 inches and every 4.5 feet. My box over here, I have a strap in here. Go all the way up to 12 inches, and after that 4.5 feet. Now they catch you on the NEC code book, guys. They say, what if you have a receptacle? If you have a non-metallic box and you don't have a strap because the hole is broken here, and you have to, it goes all the way down to 8 inches. Please put this have a note here. You go down to 8 inches, guys. This is the same, 4.5. This is 4.5. If you have a non-metallic box and the cable doesn't have a strap here, of course, it's broken, just the hole goes through it. Then it goes down to 8 inches. Down to 8 inches. That's kind of an exception. 4 inches to 12 inches. Write to 7 note for that journeyman exam. Protective devices. Protective devices must be protected against overcurrent protection device. The question is, guys, look at this. It's really interesting. Overcurrent protection device and installation requirement covers. Okay, here, conductors must be protected against overcurrent protection device in accordance with their ampacity. That's a simple rule, but that rule that matters all the time. You make a conductor, protect the conductor more than what the conductor can carry. And guys, we have an air conditioning. When we protect it based on against overcompression event according with 442.22, which is basically tells you 1.25 times full rate of the equipment, full load current, and that's how you size the conductors. How you size the conductors. The overload for AC system. The overload for AC system. I don't know how many of you guys have done that. They go 1.75 times load current of the AC system, full load current. And for this, guys, why the conductor can be smaller than the overcompression device, because these equipment have an overload load protection, like motors. I don't know if you guys have seen this scenario, which I hear all the time. Here's an overcompression device. Here's a 40 amp here, connected to a motor, a machine that has a motor, and the conductor here is number 14. Seen something like this? A 4th circuit breaker feeding number 14. Anybody seen that? Number 14. So something like this, a lot of people go nuts. Are you kidding me? Number 14 is rated for 15 amps. How would you put a 40 amps on it? The reason for this, guys, is okay on motors because motors have an overload protection. Now, most motors have a controller here, and inside the controller have an overload protection. So overload protection here will protect the conductor. So the motor itself will not take more than, because it's continuous, more than actually 12.5 amps. With the motor, it will not take more than 12.5 amps. 12.5 amps, number 14 is good. And who regulates this? The overload. So that's special condition for motors. This is one of the single most important things, guys, that you know about fuses. These are fuses and fixed. I can't emphasize the word fixed. If you deal with adjustable circuit breakers, guys, that does not apply to them. It can go from 15 all the way to 6,000 amps from this table. The most common, largest that I've seen is 4,000 amps. 4,000 amps switch gears with an overprotection device, 4,000 amps. Anybody have seen anything higher than 4,000 amps? 4,000 amps switch gears. So not a lot of people excel energy, which can give you higher than 300 amps actually, 3,000 amps. So these are standard circuit breakers. So which means if you end up with non-standard, you can custom design yourself a fuse or a circuit breaker and pay an arm and leg, or go to the next standard, up, the next standard down, depending on what the is under this certain circumstances. For fuses, there's also one and a couple of other the wall thing. If you have ungrounded conductor, guys, with multi-wire branch circuit, as we all know, multi-wire branch circuit shall be only installed on ungrounded conductor. Multi-branch circuit will supply link to neutral loads, except where limitation. There's some limitation where short if you have here's a multi-wire branch circuit here. For the most part, it has to feed line to neutral load. Here's line to neutral load, and here's my neutral. And get into exception. Here's my neutral shared between. This is called the multi-wire branch circuit. Line to neutral. Line to neutral for multi-wire branch circuit. Or it could be three-phase too, sharing it. Any questions about multi-wire branch circuit? Line to neutral load. Neutral load, except we're limited by there's some limitation where you can feed line to line. A good one is in 240, guys. You use two of them to feed air conditioning. Yeah, conditioning. For the part you can feed up to, you can feed up to 208 with some exception. 208 three-phase. And 240 single phase, 240 single phase. You can use an AC unit here and feed it from three whole circuit breakers tied together. I'm not going to go there because there's some exception and so forth. Looking on the premises, circuit breakers must be really accessible when you put them in the premises. You can't put them in a place where they're going to be higher than 6 foot 7 inches. Otherwise, short people like Chad can't access them, and that's true. So put them as you put your panels, guys. This is a big deal. When you put your panel situated, you go to the protection device and make sure as you mount your panel, you go from here all the way to the ground. Sure, it's not more than 6 foot inches. That's how they catch the inspector. It has to be 6 foot 7 inches. From this option device. Any question guys about this? Question about this. So you can also put it in the vicinity of equal material like clothes. You can put them in a closed closet. If you have an overcompetition device. Bathrooms are prohibited in residential. Not located bathrooms. Overcompetition device must be located in the bathroom with dwelling units, guest rooms, guest suites, and hotels. If bathroom at the U of M campus in a commercial building, a panel inside that, there's nothing wrong with that. I don't know why would you do that, but a bathroom is in my house. I can't put the panel inside, overcompetition device inside the panel. You can't locate it over steps, guys. That came in 2011. And if you're going over steps, put the panel right here at the top of steps, not landing. The landing, okay. The steps are no. Must be mounted in vertical. Include the panel that has overcompetition device, guys. They want it to be in vertical position unless this is impractical. So you cannot put my panel this way. Go ahead. So mostly the panels that they are to be mounted vertical. Unless it's practical, there's some exceptions, but the idea is you put your panel vertical. Circuit breakers are permitted horizontal if the circuit breaker is installed in accordance with there's some exception. Can I put my circuit breaker horizontal? Yes. There's some exception with and restriction on that one. If in the vertical position, off is down and on is up always. Up is on, so down is off. And the marked on off indicating types. Marking used as switches. If I have a circuit breaker, the question would be, can I use the circuit breaker, guys, as a switch? No problem. Circuit breaker is used to switch 120 or 277. If switching fluorescent lights because the inrush, guys, it has to be rated as a switch for high intensity discharge. If it's switching high intensity discharge light, they have to be marked with HID, high intensity discharge lamps. The reason this guy is fluorescent, high intensity discharge, they have inrush on them. If you don't rate the circuit breakers to handle them, you can damage your circuit breakers functions. So if you have a short circuit, they might not trip. How can I damage a circuit breaker? If I have a short circuit, I need the circuit breaker to wake up and trip, so I'm not trip. And guys about using the circuit breakers as switches, and you jumping guys through the applications. Circuit breaker with a straight voltage rating permitted on where the nominal voltage between any two conductors does not exceed the circuit breaker voltage. So I have a circuit breaker that says 480. Can't install that circuit breaker on a system that's higher than 480. Circuit breaker with a slash rating permitted on solidly grounded system. The nominal voltage of a conductor to the middle does not exceed the lower of the two values, and the conductor does not exceed the higher values. For example, if I have a circuit breaker that says, a good example would be, if I have a circuit breaker that says 240, 20 volts, right? I can't install this circuit breaker in a system. I can install it. This is a circuit breaker. I can install it on a system, guys, like this. But let me show you another system where I can't install it. Suppose I have a delta and like this, and grounded, a grounded delta, right? Phase A, phase B, and phase C. Now I can't install, and this is a 240, corner grounded delta volt. I can't install this circuit breaker on a delta corner grounded, and the reason for this is because the line to ground voltage is 240. It's 120. If you guys take the voltage from here to here to the ground, is 240, and it's higher than 120 what this circuit breaker is rated for. So that's where, I don't know if I encountered this. That's what they're trying to say. They're trying to say if you have the circuit breaker two ratings on a 240, 120, anything line to neutral has to be 120 or less, anything line to line has to be 240. And now we're in a situation where it's corner grounded delta. Any more friends? Any questions? Any? Our circuit interrupter, and I'm running here quick because I'm looking at the clock here. Our circuit interrupters in dwelling only, so don't think about it in any other locations. Needed in 15 and 20 amp branch circuits in the following location: bedrooms, family rooms, dining rooms, living rooms, parlor, library, den, sunrooms, blah blah, all the hallways. Basically, any place that you do not need a GFCI. Any place you do not need a GFCI. You know guys how these work. They look at the signature of an arc, line or serial, and then if it witness the arc, it's off it goes. Any questions guys about the arc fault circuit interrupter? Question arc fault circuit interrupters. A lot of stories about them that they trip on loads and nuisance tripping and so forth, but that's a different story. Switches. Switch, where do you need a switch? Here's what the code says, guys. Habitable rooms. Any room that's habitable that you can use. At least one wall switch controlled lighting outlet must be installed in every habitable room and bathroom of a dwelling unit. The question about the wall switch, it could be the picture has of it, but any place basically habitable needed. What is it? Additional locations, stairways and garages, exterior entrances, these are needed switches. It's for outdoor, it doesn't need a switch on all. It could be remotely controlled with an occupancy with a moon detector, so it doesn't need a switched wall, it's located switch. Some spaces, at least outlet switch is controlled by wall switch, must be installed in the attic, on floor spaces, utility rooms, and basement used for storage or containing equipment. So at least one light outlet that contains switch. So the light could be basically a switched lighting fixture with which, or is controlled by a wall switch. And we all guys in the basement, you can have the lighting fixture right here, and with the little switch that you can switch it, right, which is a few of these. Or you a switch on the wall, they're switching their fixture. Either way. Okay, that's basically what I have for you guys. I ran through the other things. Any question, guys, about the switches? Any question about the switches? Questions about the switches? So you need a switch in every switch. Your lighting outlets, guys. Your lighting outlets can be a lighting fixture or can be a switched receptacle. A switched receptacle. The only place in the NEC code book, one of the places in the NEC code book, we can't have a switched receptacles, as we all know, in the bathroom and kitchen, garages. You need also in unfinished basements. These places you need a lighting fixture, basically. But have a bedroom, living rooms, dining rooms, and this is you can have an outlet, a switched receptacle, as your lighting outlet receptacle. Any question about switches, guys? Any question about switches? The bedroom, that's the basement. Trying to see if we got anything else. Devices. Okay. Yes, that's all what we have. Any questions? So that's basically what we have for you. Talked about dash voltage for here. We talked about this. I don't have time to give you the poll, guys, over here. Yep, you know what? We have 5 minutes. Let's take the poll here. I'll give you the 5 minutes to finish the 2 on that one, and then that will be basically it. Let me see here if I can get you quick. Okay. Okay, there you go. Let's go and open it. Option 5 minutes. Good. I'll go ahead, guys, and answer these. There are 6 problems. Should work, and then we'll call night if you guys don't have any questions. All right. Reminder, guys, that next week we will be convene on Monday. I'm going to write it right here. Just keep reminding people. Monday, April 8th. We're going to have a scheduled meeting. Please make it accordingly. Monday. Okay. Guys here. All right. All right. So, escape. Okay. Okay, my friends, I know you is up, guys here, but bear with me a second here. Okay. Perfect. Okay, I'm gonna go share the results with you guys. Okay, the one to mention, guys, is last one that talks about if the voltage on the primary is the voltage is more than 300, then the secondary must be grounded. For control transformers, that's a big deal. So if voltage in the primary, for safety reasons, if your voltage is more than 300, so that will cover 208, 240, 120. You don't need to ground the secondary. But if it's more than 300, then you have to ground it. So that's what I want to show. Okay, with this, my friends, that will bring us to our end. Any questions before we call it a night? Any questions? How about an expert Chad or raise your hand? I can hang around here if anybody has any questions. Next week, we're going to continue to talk about planning, guys. We'll talk about more layouts and receptacles and some calculation and so forth. And be the last session for this class next week. And so, if you have any questions, guys, just a quick reminder, if you have not given me your homework, please do so as soon as you can. And we will see you on Monday, April 18th. Okay, friends, and good night.